Welcome everybody. It should be Asia in Asia area. We are in the afternoon, so good afternoon. If you are probably outside Asia, that will be early noon time or in the morning. Today's the topic is about the sustainable energy and basically one of the theme that we set out for the competitions. And the purpose of today's sharing is to give the student a bit more insight about this topic. And in fact, we have a supporting material deck available on the web as well. Later on, Sky will introduce a bit more about that particular resource material deck. And so what we shall do, we just go in to this particular topic. Now, when you talk about sustainable energy, if also you want to do a project on sustainable energy, you may have to ask yourself why we need that. And this is a historical temperature data set collected since 1860. So if you look at the past 100 years data, you can see that our temperature actually keep rising since 1920. So it's almost 100 years ago. And the rate of increase is actually speeded up since 1960s. So in the past 60 years, the increase in the global temperature is a trend that cannot be ignored. And in fact, if you look at the data by 2023, we already reached the 1.5 degree Celsius increase as we said in the Paris Agreement, that we don't want to see that happen. But in fact, we already reached that goal. Now, the next step is, can we do something so that we can avoid the temperature increase to reach 2 degrees Celsius? So this is one of the major drivers for all the energy transformations in the coming year, in probably decades. If you look at this curve, it's still on the rising trend. It took 60 years to rise. So how many more years do you think it take? At least to plateau and then to decrease. It's probably another 100 years. Okay, it's not that. So because of that rising temperature, we are experiencing a climate change impact all around the world, no matter where you are. In the Asia region, in particular in Hong Kong or the South China Sea area, we are constantly affected by typhoon, and the strength of typhoon keep increasing. And this year we have more number of typhoons than other years, and 2 severe typhoons hitting Hong Kong already. And then we have location with heavy rainfall and also location with drought. The location or the regions in the world that do not have water, the ultimate consequence is extreme heat, and it may also cause forest fire because of the dryness of the tree. For cities or country which is actually in the middle of the sea, the rising sea level is another threat for the livelihood of those people living in these countries. So the impact of climate change is obvious, and it's escalating in the past 5 to 10 years. And this is something that we could not avoid. So what is it related to energy? Because if you look at this, the temperature, and if on top of it, we have also another data set, which is the CO2 level. The CO2 level around the world has increased in the past 60 years by 30%. And this kind of CO2 increase in terms of concentration is no doubt due to our tremendous use of fossil fuels. If you look at the statistic, as I show on this slide, fossil fuels provide 85% of the world energy consumption. It accounts for close to 80% of global greenhouse gas emissions. Even though in the developed country, we enjoy sufficient supply of electricity, but in fact, around the world, we still have around 8 million people they do not have electricity supply. And around 2.6 billion people are actually relying on pollutant fuels. and such as wood, charcoal for cooking or their daily life. And the cooking use of biofuels actually estimated to contribute to around 7 million deaths every year. And in order, as I mentioned earlier on, to really enable us avoiding 2 degrees increase in the global temperature, we have to do a lot, in particular, transforming our energy production, distribution, storage, and consumption. I would talk about a bit more because energy is not just producing the energy. So we also, once you find the energy sources, you also need to think about how you distribute the energy, how you store the energy. All this activity may incur costs. That's mean money. In particular, when you look at sustainability, you cannot ignore the cost. You may have brilliant technology, but you also need to assess how much it costs to implement the technology and to scale it up for universal use as well. Ultimately, we would like to see definitely clean energy could be freely or readily available to majority of the human being on the earth, so that it will help to mitigate against our climate issue, improve our human health, as well as driving the economic developments all around the world. That is the ultimate goal. If we have access to clean and reasonably priced energy. Now, what is sustainable energy? And when you talk about sustainability, basically it's not just referring to energy. We talk about the whole concept of sustainability. Why we need to consider sustainability is because, in general, the natural resources on Earth are finite. That means limited. If we have infinite amount of resources, actually no one need to consider sustainability at all. But in reality, on planet Earth, all our resources on Earth they are limited. That's why we need to maintain the balance between how we're going to use it in an environmentally friendly way, economically, and balance. That means equality, to have equal share among our human race. Now, if you ask about if an energy is sustainable, and the second paragraph, it just gives you some definition. Basically, what we want to do is, if we use that particular type of energy, it should meet not only our current needs, but also without compromising the ability of future generations to meet their own needs. So we cannot use up all resources in such a way that a few generations down the line, they don't have access to that energy sources at all. And in order to be sustainable, the energy sources should also look at its impact to the environment, to the economy, as well as the society. Actually, from a sustainable policy point of view, we call the environment, economy, and society as the 3 pillars of sustainability. So whenever we propose any sustainable measure or new innovation, we need to consider these 3 aspects. When you talk about what kind of impact most likely brought about by all this energy use, there are many greenhouse gas emissions as well as air pollution, because a lot of the energies the way that we use energy is to burn them. That means to go through the combustion process. When you burn a fuel, no doubt, the impact of this process is to produce air pollution. And to sometimes they may even have toxic waste that we need to consider. No matter how good it is in terms of the intention, but we also need to be careful the product that they're going to produce when we use that particular fuel. In terms of renewable energy sources, we commonly know about wind energy, hydro energy, solar power, as even some countries may use geothermal energy as well. However, they are not necessary, even though they are renewable, but they are not necessarily not necessarily environmental friendly. Some of them may have and create certain environmental damage. So I will show this later on. However, in comparison, by implementing this, what we call renewable or green energies application, to a certain extent, their environmental damage is relatively lower as compared to the use of conventional fossil fuel sources. And that's the reason why we tend to move away from the use of fossil fuel to much higher percentage usage of renewable energy. But it doesn't mean that it does not cause any environmental harm. It may still have some harm, and we need to consider. One of the reasons why solar power and wind power become so popular nowadays is because if you look at this curve, the cost of establishing a solar farm as well as a wind farm dropped tremendously in the past 10 to 15 years, or around 20 years time. And if you roll back the time 10 years ago, or even 15 years ago, establishing a wind farm or solar farm is still too expensive. And the cost that you're going to invest on it to establish the farm could not justify the cost that you produce electricity from conventional coal-fired plant or even natural gas plant, not unless you have heavy subsidies from the government. So in the early stage, most of these plants were constructed under the subsidies provided by various governments. And one of the reasons why the government want to invest in it is not just for political agenda, because when you want to advance the technology, you need to start your first step. So very often at the beginning, government interventions or government subsidies is an important element. It is not possible to really advance a certain technology without sufficient financial support. So financial support is an essential considerations when we look at the viability of technology. In the next few slides, I'm going to talk about different type of renewable energy that all the students you may be familiar with. But what I want to do is not just to talk about the good thing, but also talk about the bad thing of each type of energy source. As you can see from this slide, I just showed the wind farm. Now, definitely the wind farm is trying to harness the wind power, which is readily available on our planet Earth. And it could be the good thing, the benefit is could be cost effective in the long run. It can actually propel our technological advancement. And however, because of the rotating blade, it is not bird friendly. So very often you have to really design your wind farm at locations that to minimize the impact on wildlife, in particular birds. And also, wind farms tend to have noise pollution. Basically, you have an acoustic concern, and you need to position the windmills in a certain location in such a way that you can avoid or minimize the environmental impact. And it is common, no matter whether it is wind power or solar power, one of the concern is inconsistency in terms of electricity generations, because the rotation of the fan is depending on the wind speed. So the wind speed is not constant. That's why most of the engineer has to design the system in such a way to harvest the wind power as a certain optimum or designed speed. But what happens when the wind becomes so strong, much stronger than the design speed? This is the bottom picture. And in fact, a number of incidents happen is because the wind is so strong, in particular in the past few years. And some of the wind farms were destroyed. by strong wind, in particular typhoon or hurricane. In different, it named differently, but it, from the physical term, it just means very strong winds. When you encounter strong winds, you are not, it's unavoidable that some of the windmills will be damaged. And this is something anyone who are going to get themselves involved in the wind farm business need to be concerned of in the future. How are they going to mitigate against the impact of strong winds? Or just simply, okay, replace it subsequently. But how fast can you replace the system? This is another question. Now, next is about solar farm. Okay, so it's common. One of the essence of solar farms, in order to generate sufficient amount of solar power, is you need a large surface area. Virtually, if you have a large enough area to put large number of solar panels on it, then you can harvest enormous amount of solar power. However, the shortcoming of solar power is also limited by the sunlight availability and also dependent on weather. If the weather is cloudy, you may not be able to harvest sufficient number of hours of useful solar power. And that's why in different parts of the world that they have a different potential. In Middle East, virtually near the equator, they have the highest potential or the largest number of hours of available sunlight. And in some Middle East country or country with sufficient sunlight along the equator, they can enjoy over 4,000 hours of sunlight per year. But in other location, if you are at high or different altitude, like in Hong Kong, we can only harvest something like just over 2,000 hours per year, or sometimes may not be able to reach that number. When someone tries to invest on solar energy, they have to think about two things. First of all, whether they have sufficient amount of land to put large number of panels to harvest sufficient amount of energy. And then the other concern is, can they produce the panel in a cheaper manner, as well as secure it in a safety manner? The bottom picture I show is also the aftermath after a typhoon. Virtually, solar panels being destroyed by a typhoon easily. Partly because normally the structure is not designed to be typhoon proof, I would say. And because if you can, definitely you can build a very strong structure to withstand strong wind. But in order to do, you have to invest more money on the infrastructure. So that for the investor or for someone who's looking at solutions for improving the solar power, then they have to think about how can they design structure that can be easily deployed, but at the same time strong enough to withstand typhoon or other strong wind effect that may damage their assets. Hydro, okay, definitely hydropower is good in the sense that once it's built, it can really provide or supply electricity or power supply for a very long time. And it's clean and renewable. It's simply relying on the potential energy stored at high level and dropping to a low level simply because of physics. However, when you build it, it actually disturbs the ecosystem on both sides of the riverbank of the water sources. And it also may affect the hydrology of that part of the country or the region. And also it's very expensive. It's a very high capital investments, I would say. And also it's an engineering challenging task. It depends on the capability of individual country to do. But once you have that, if your country or regions have good resources of hydropower and you already have that power sources, then you can start thinking how to use it, how to make good use of it, and also how to enhance the benefits come from the hydropower. Now, the fourth one is the geothermal energy. And the principle of geothermal energy is not too sophisticated. Basically, our planet Earth, the core of our planet Earth is very hot. It's virtually like a hot cake inside. And then there you have molten rocks inside the core of the Earth. So the idea is to pump water or some kind of liquid into the rock to harvest the heat from the rock in such a way that by pumping the hot water, or some of them even become steam, out from the hot rock, then the steam can be used to drive a steam turbine. And after the steam turbine basically is an electricity generator. So the principle is it's to make use of liquid to harvest the heat coming from the earth underneath, could be hundreds of kilometers down. Drilling down is not a difficulty because drilling the rock we have been doing that for exploration of oil and petroleum. So definitely engineering wise, we have the technologies to do that. But then we also need to think about, does it mean that we have no environmental concern? Not necessary. Because in drilling, by drilling the earth, you may actually crack the structure of the earth. To a certain extent, some unwanted material may be released during that kind of drilling process. So you need to have very good engineering planning to drill the hole. And also when you harvest the heat from the earth, sometime you may also encounter unpleasant material coming out, sulfur. Some kind of sulfur, like you go to a hot spring, you might have sulfur coming out from the spring, and that is the same reason. So there are always pros and cons in all the various type of what we call renewable energy. Now we come to another type of what we call zero carbon emissions energy, nuclear power. It seems to be not really user-friendly. Not that many countries, and some countries even try to refrain from nuclear energy because not just the cost, but the risk of nuclear accidents. Basically, the nuclear waste is radioactive, so it's actually you have to spend more money to handle the nuclear waste. However, nuclear plant, after it's built, if you run it properly for 30 to 40 years, there's no problem. And France is one of the countries that make use of nuclear, high percentage of nuclear power. So that enabled them to rely less on traditional fossil fuel, and also at the same time to keep their electricity generation at very low carbon content. So they're actually producing electricity at very low carbon emission level. And however, we cannot claim nuclear energy as a renewable source because nuclear energy is dependent on radioactive materials. Radioactive materials is limited. The availability is limited on Earth. So we cannot regenerate the nuclear fuel easily. However, there are new developments around the world. At the moment, what you can see from the picture is really large nuclear plant, but technologically, the scientists are designing much smaller plants, what we call a micro nuclear plant. So a lot of investments going on. I'm not going to go into detail for the micro nuclear plant today, but you can always easily find the information from the internet. Now, you may heard of nuclear fusion. Okay, fusions is to a certain extent less hazardous because the product of the fusion itself is not radioactive material. However, the process is not easy to control. I have the opportunity to visit one of the nuclear fusion plant in China a few years ago, and the experiment has been going on. They are improving the technology in such a way that they can extend the, the duration of time that they can produce electricity. Uh, it's interesting. If you look at the picture on the left, the idea of nuclear fusion is simply to generate a beam, many beams, particle beams, when they circulate around a magnetic field. And then they contain the plasma inside the magnetic field in such a way that by constant collision, bombardment, and then generate high temperature. The temperature could go up to 100 million degrees Celsius. So under that kind of conditions, the particle may collide and fuse together like the slideshow on the bottom right. So once the particle fills up together, the additional energy will be released. So this is the whole idea of nuclear fusion. However, it is not easy to contain the particle inside this kind of environment for too long. It requires a lot of research in the material sciences. So what kind of material to be used for producing that container, and the type of magnetic field and the duration that they can maintain the production of electricity. We are talking about, at the moment, 1 or 2 minutes of production. Initially, when they start this experiments, they're talking about several seconds of energy generation, and now they're extending it to the minute level. Definitely, we're looking forward to the future to see. I don't know how long it will take, but probably in the young scientist generation, in your generations, you may have a chance to see this actually into production. Now, another emerging technology is about synthetic fuel. Now, when we talk about renewable energy, we tend to harvest the energy actually produced by the nature. Okay. However, one of the shortcomings of this kind of energy is they tend to be produced in area very remote. Okay, not many people actually live around the plant or the site that producing the energy. So how are they going to transport the energy produced from the site of production to the user? This is a basic problem for any renewable energy plants. How to store the energy, how to transport the energy. Synthetic fuel is one way to transform the energy, the green energy, no matter which is solar or wind or even hydro, to another form. All these form what we call virtually is an energy storage system, but it is stored chemically. The way, if you look at it, basically, if you have a renewable energy source, you can use that electricity to produce hydrogen first. And basically, you have water through the electrolysis process. You can split the water to extract the hydrogen out. Now, this hydrogen molecule, we call it green hydrogen because it's produced by green energy. Does not have any carbon footprint. Once you have the hydrogen molecule, you can combine it with another carbon or carbon dioxide molecule. Now, once you combine it, then it becomes hydrocarbon. Chemically, it's just like a Lego. You can add whatever number of hydrogen and carbon together to formulate the type of product that you want. So on my right-hand side, I list out 4 chemicals or 4 type of fuel. The first type of fuel is hydrogen. As you might know that around the world, hydrogen has been identified as one of the potential green fuel in the future. How are you going to use it? You can use it either directly in a hydrogen fuel cell. That means you inject hydrogen into a fuel cell that will generate by combining hydrogen with oxygen in the air again, it produces water and electricity. So this is the direct way of we generate or recover the energy stored when you form the hydrogen. The other type of what we call E-fuel, we have E-methanol, E-LNG, E-ammonia. Why we need to produce this type of fuel? When we use this type of fuel, you still need to burn them. Of course, for hydrogen, you can also burn them in the combustion engines, but it is more energy efficient to use it for generating electricity. But however, for e-methanol, e-LNG, and e-ammonia, the reason why we want to produce them is provide a transition change for the user. Because we're not just producing the fuel, we also need to concern about the user. How are they going to transform their device, no matter it's a car or a ship or an airplane? How are we going to transform all this application from conventional combustion method, relying on combustion to provide the propelling power, to something else? So people may say that can we use electric fan or for all this device in future, but not at the moment. It's just not powerful enough to generate sufficient and propelling power for these machineries. So a lot of this existing machinery, no matter whether it's lorry, heavy-duty vehicles, ocean-going vessels that transporting all these cargoes to different ports, even aircraft, it may take many years for them to be converted to use some other dynamic or propelling source. But at the meantime, at least for the next 20 years, we may still need to rely on combustions to provide the driving force. So what can we do? What kind of low carbon fuel can we supply to this type of application? I forgot to say there's another called SAF as well, Sustainable Aviation Fuel, for the aircraft use. I missed out that one here. So no matter it's methanol, LNG, ammonia, these three fuels are mainly targeting for the use in either vehicles or maritime sector. That's mean ocean-going ships. The liquid nitrogen, the liquefied, basically natural gas, what we call natural gas, basically is a methane. So it's a liquefied methane, you can say. It's already in the market. A number of vessels has been using LNG as their propelling power. And some of the domestic use, like our town gas or even some gas pipe, they're using methane as their cooking fuel as well. So what if in the future, when we have abundant amount of renewable energy, the technology is cheap enough, then we can produce all these fuel in a much more cost-effective way so that we can replace the fossil fuel directly. That means we don't need to dig up liquefied methane or natural gas from the ground. So we can actually producing them in a more green way. So this is already happening, this type of synthetic fuel. Okay. Green methanol, LNG, and hydrogen is already in the market. Ammonia is still on the way because the application is not available yet. Actually, coming hand in hand with all these renewable energy applications and developments is the energy storage system. Because I've already mentioned, all these renewable energies, but the way they produce energy is not consistent. That means it's not stable. It's also have peak and low. So it fluctuates significantly. It is not suitable to supply directly to the power grid for the general use. Therefore, at the moment, one way to handle this problem is to store the energy generated from these renewable sources into an energy storage system. And very often, which is battery energy storage system, what we call BESS. Now, these are two examples, one in Singapore, one in China. In in terms of demonstrations of the implementation of this kind of battery. It's just like a container, many containers of batteries, okay, putting together. Tesla, you may heard of, also are producing this kind of energy storage system as well. And I would say it is becoming a major business for many energy company now to really provide energy storage services around the world. This is another issue we need to tackle, which is what I mentioned earlier, the transportation of energy. Now, the target of the energy itself is electricity. You produce electricity like far away, because very often the source of the power plant is far away from the customer. It could be thousands of kilometers away. We cannot actually transfer or transmit the electricity directly through such a long distance with the conventional cable. So at the bottom, you may heard of high voltage and extra high voltage. Now the latest term is ultra high voltage. The reason why we want to use ultra high voltage is just a simple physical law. When your voltage is higher and you put on the same cable, the current will be smaller. That means you can use a smaller electric cable for the overline or overhead or underground cabling system. And also the energy loss through that particular transmission is smaller if you have higher voltage. And that's the reason why the technological development is moving towards the ultra high voltage regime for developing our electricity grid, so that electricity provided or developed in certain location can be transmitted or transferred to the user, which is over 1,000 kilometers away from the production position. And this kind of development is also driving a new technological advancement. It still have a lot of room for improvement yet. And so is something the student can think of if they are interested in this type of work. And this is another emerging technology. You may look at it. What is it? It's just glasses. It's true. Now, as I mentioned earlier on, when you produce solar power from solar panel, normally the solar panels are located in the countryside, in the remote area, in the large solar farm. But here, the solar farms is actually built, integrated with the building. So the building become a mini solar farm itself. The way to do it is a new type of building material. We call the building integrated photovoltaics. Virtually, we integrate the solar energy production element inside a piece of glass, virtually your window. We can turn the windows into a solar panel. We can actually, this kind of BIPV can be used to substitute traditional construction elements such as roof, facade, and skylines. And it become more and more popular around the world now. As I show here, one example is in Paris, the other example is in mainland China, Shenzhen. So actually, the whole building is covered by this type of BIPV. And one of the advantage of this kind of applications of solar panel is, first of all, it's not just they can produce solar power. Because if you think about if the whole city, each building can become a tiny or mini PV panel or solar power generator, then you will have a lot of mini solar power plants in the city. Each building become a solar power plant. All right. Then your electricity does not need to be transmitted long distance. The source of solar power will be located close to the customer, to the user. This will reduce the demand of a lot of storage system as well as expensive high voltage transmission system. So this is one way the technology is moving. And also you can see from the right-hand side example in Shenzhen, the glass can also be colored. So the glass itself can become an artistic kind of design material to provide extra dimensions of design flexibility to the architect. Finally, after we have heard about all these different technology, I would like to give you a holistic picture of what will happen in future. And basically, we have many different type of energy sources. It could be wind, it could be solar, it could be thermal, hydro, many. Okay, and then you need to transmit it to the user. Once you go to the city level, will have a number of elements that will utilize the electricity. And at the same time, the customer or the user itself can also become a producer of energy. For example, the EV, the electric vehicle. You store energy in the electric vehicle, but when the vehicle is parked and connected to the grid, when it's not used, it becomes a battery energy storage system by itself. So the concept of microgrid is in the development. So in future, microgrid will be one of the major electricity supply infrastructure that will help harvest the renewable energy developed or produced by individual buildings or device that will feed back to the main grid and combine with the utility grid supply to help balance out, so we don't need to overbuild the power plant in such a way that a lot of wastage in terms of infrastructure's development causes. So optimizing energy use is also another aspect of development which we need to pay attention to. So this is my last slide. I just stop here and welcome for Q&A. Okay. Maybe I
Thank
just
you,
go.
Kenneth. That's very insightful. Hopefully, it will inspire our participants here and help you further fine-tune your problem statement. So you may see at the bottom of the webinar the Q&A button. So if you have any questions, in mind, you can just type it there. I have two questions that I received from you earlier, more on the like sign up administration side. So let me share my screen. So I'll start addressing those questions, and please feel free to type in the Q&A for us to answer in this live session. Okay, I hope you can all see my screen. So the first question I have is actually from Mohammed. So thank you for your question. It was more on how you will present your solution, whether it will be online presentation or if it will be in person. That's a good question because I can understand you're overwhelmed with a lot of information. So hopefully what you can see on the screen now, the GSC actually has three phases. So phase one is Ignite, which is where we are now. This is more about teaming up, research the problem statement you want to work on, and the design solutions. So the deadline for this is the 3rd of November, and the format for this is just online. Maybe I will go on the next slide, will show you more what's required, but just on this slide, phase two, when you get through the next phase, that is when you join the regional finals in person, where you will present your solutions to a panel of judges. And hopefully when you get through that, it will be the grand finale. So for regional final, it's depending which region you are. For example, for us in Hong Kong, this is a Pacific Asia and Australasia region. The regional final would take place in Zhejiang University in Hangzhou in China. And for global finale, everyone, the finalists will go to Munich. TUM University will be hosting in April. So just on the next slide, in terms of deliverables, this is the website. If you have not already registered on the Global Sustainability Challenge.org website, I encourage you to do so because there's a lot of resources there for you to reference. So on this, I've circled the highlighted program guide. You can see when you scroll down for phase one. So one is a team registration. So basically register yourself and form teams. We take up to recommended is up to 6 people per team. The 2 deliverables, one is on the document outlining your solution problems. So the requested format is in PDF of a file size maximum of 10 MB. And then the second one is a 2-minute project overview. So for phase one, you do not have to present in person, but just record something to produce a 2-minute tops video to summarize and present your solution. So that's more on the deliverables. And I've also received some questions on if there's any guidelines on what to put in the PDF. So when you go into the website, go to a participation form. When you scroll down on the right, you can see a download template. Then there will be more guidelines on what we suggest you can include. So I find that really helpful to guide you through your thinking process on what we're looking for. And then there is also something called the resource library. I think what Kenneth shared with us is really useful today in terms of like the challenges, the trends happening in the sustainable energy space. And here, if you have not already seen it, it's a resource library, which is just launched last week. And on the left, you can see there's 2 themes. One is sustainable energy. The other one is adaptation and resilience. When you click into one of them, so I'll take a sustainable energy, which is our theme today, you will see there are quite a lot of resources. We try to help provide clarity on what we suggest you read. So must read more on the theme overview and then the detailed problem description and some examples to help you frame your problem statement. And there are more on the left, you can see core concepts and the foundation and then exploration and application. So please do explore this space there. And again, please do register if you have not already, because once you register, even if you haven't formed teams already, you can find friends on the platform. You can invite them depending on the skill set. You can network with them, chat with them. So it's a wonderful space. The whole idea is a platform to network with like-minded individuals. Hopefully this will help you a bit. And the other question I received is from Matthew. Let me pull up his question. He's asking if currently he's working on a research paper. He asked if he can repeat the results of the experiment that's already on a peer review for this challenge. So our suggestions is that you can, but then definitely don't just copy and paste, but further develop your idea through this challenge. And I pull up this page here, it says evaluation criteria. Hopefully, by having this framework will help you further define your solution. So you can see that phase one is Ignite. These are the different weightings and areas we're looking for. So there are 5 pillars we're looking for. Phase one is more weighting on the problem definition and on innovation. And for the later part, you can see the build and shine more weighting heavier on feasibility, execution, impact, and on the storytelling. So hopefully this helps address your 2 questions. And I just put on the screen here, if you have any more, I have 2 emails here. The top one there, contact@globalsustainabilitychallenge.org, is our team. One of our founding partners, Stanford, they are managing this. The second one, we're also one of the founding partners. We also have another role, which is the regional ambassador for the Pacific Asia and Australasia. So if you have something more regional specific, you can reach out to us on the second email. Both Kenneth and I haven't introduced myself properly. I'm actually from Hong Kong, USC as well. I'm from the Sustainability and Net Zero Office. So that's why you can see the second email is at UST. And those are the 2 questions I received earlier. And I think we have a few more in
Maybe I try to answer 2 technical questions which were
Sure. Maybe.
submitted early on. One technical question is about I talk about when it comes to electrochemical storage beyond lithium-ion technology, what innovations is the industry looking forward to accomplish within the next few years? What will be a useful project idea to combat these issues? Basically, because you are talking about the next few years. So if in the current arena of energy storage, other than lithium-ion technology, that means using battery, you can also consider electrochemical capacitors or fuel cells. Okay, and there are three types of battery, capacitor, and fuel cell. There are three different types of technologies, and to serve the same purpose is for energy storage. So if you are interested in energy storage, I would suggest you look into these three different types of technology. Even though for lithium ion is a battery technology, right now people are moving from lithium ion to many other different types of chemicals. Even some people talk about sulfur. The reason why is they want to use some kind of chemical component which is readily available rather than rare sources, and also not too expensive. And that's the reason why people, when you are interested in these subjects, they are looking at material science stuff. They're looking for new material that can replace lithium ion but still perform equally. And then the capacitor and fuel cell there are two different ways to do it. Now, the second question is about, is it possible for utilizing temperature difference to generate electricity to cope with global warming? Now, as actually you talk about temperature difference. Normally we harvest temperature difference through something called heat exchanger. When I introduce geothermal energy, it's basically make use of the temperature difference between the core of the earth, the underground earth, and the surface earth, because there are big temperature difference. When we pump the water in, then the water will absorb the energy from the earth, and when it comes out, becomes steam. And actually, this is how we use the energy difference to drive some kind of mechanical device. Now, if you want to just utilize the temperature difference without any moving part, it is difficult. But it is not impossible, but you need to think about, can we find material, in particular metal, that because of temperature difference, that will enable the electrons in the chemical to move. That is current, that is electricity. So you need to find the right kind of material that may have this kind of behavior. Okay. And I also saw a question about any past winner. I would say, sorry, you will be the first winner if you join, because this is the inaugural sections for this particular competition. This is the first year we start this competition. And the question whether I can share this PPT, yes, I can. I can put it, package it, and put it in the resource deck. So for all the students to make reference to. Hang on. And also, I want to focus on adaptation and resilience. Can I present my project in this? Oh, this is more administrative. So I leave it to Sky to handle the administrative questions. Okay.
I think it depends on what kind of research paper you're doing, because as I understand, every kind of research has its different working parties. I suggest you can send me an email and give me more details, and we'll guide you through to make sure that we address your question. And I'm seeing one question from Evans. You're asking, you're from Africa, can you still participate? So the answer is yes, please, by all means. So this Global Sustainability Challenge is actually open to any students around the world. As long as you are an existing student from college or university, you're welcome. Please do. We welcome your participation. I have one from Evans. should this innovation be, you're asking social enterprise, I guess you're asking if it should have an impact on the society, if I'm interpreting your question correct. Absolutely. So I think at the beginning, the phase one, the focus is more on the problem statement definition. And one of the process to understand your problem, to define your problem, is to speak to the stakeholders, speak to the people in your local environment, to people there to understand the problem, and then hopefully it will bring impact to them. And later on in the stage is all about like feasibility and the impact, like scalability, how big an impact it can be to the people, your target audience of your solution. Hopefully that answers you. And then I think that covers.
There's one on adaptation and resilience.
Okay.
The second, I think, yeah, the second last one.
Okay. Yeah, that one is the one that on research paper I
Right.
to
Okay.
earlier. I suggest please do email me with more details so I can guide you through because every paper is quite different.
Okay. And also, one student asked if they can reach us because they are HKUST student. Definitely, you can also send email to make an arrangement because our office is on campus. So you are welcome to come in person to have a chat. Yeah.
Yes, I think one of the question is asking if I can share the email again. This is our email address. This first one is a generic mailbox. If it's region specific or USC students, please, you can email us through the second one, but either one can reach us, to be honest. So the Stanford team will forward it to us if it's anything specific to our region. So I think that wraps up our session and it's perfect timing. It's just 6 o'clock. So thank you once again for Kenneth for your insightful sharing and for all the students for making time to join us in this 1 hour session. Thank you. So any questions, please do email through. So hopefully this is helpful. The recording of this webinar will be put on will be shared out on the GSE platform, and the PowerPoint of this will be shared out. So thank you very much. And thank you, Kenneth, and have a good evening.
Okay. Yeah. Have a good weekend too, everybody. Bye bye.